Hello and welcome to today's video. In this session we want to solve the exercise exploiting NoSQL operator injection to extract unknown fields of the Web Security Academy. For this we need Burp Suite, whether in the community or professional version. We will discuss the limitations of the community edition when they occur. In the video description there is a link to a comprehensive write-up of this exercise. The first step is to ensure that Burp Suite is running and correctly configured. We will use Burp's integrated browser to interact with the target web application. Go to the Proxy tab and ensure that Intercept is turned off. In Burp's browser, navigate to the login page of the target web application. Enter the following credentials: username Carlos and password invalid. Click Login and observe the response message. Notice the error message displayed on the screen, invalid username or password. This confirms that the application has a user authentication mechanism in place. Now that we have attempted a login, let's analyze how the request is processed. We will capture the login request in Burp Suite and modify it to test for potential vulnerabilities. In Burp Suite, navigate to Proxy and the HTTP History tab. Look for a post/login request in the list of captured traffic. Right-click the request and select Send to Repeater. In the Repeater tab, locate the request body containing the login credentials. The original request should look like this. Replace the password value with a NoSQL injection payload. Click Send to submit the modified request. Observe the server's response. If the response changes to account locked, this suggests that the application has accepted the NoSQL injection attempt. This confirms that the $NE not equal operator is being processed by the backend, indicating a vulnerability in the authentication mechanism. In Burp's browser, attempt to reset the password for the Carlos account. When you submit the username Carlos, observe that the reset mechanism involves email verification, so you can't reset the account yourself. Now that we have identified a NoSQL injection vulnerability, let's investigate whether the web application executes JavaScript inside the request body. We will test this using a $where clause. In the Repeater tab, modify the request body as follows. Click Send and observe the response. If the error message invalid username or password is returned, this suggests that the condition was evaluated as false. Modify the request again by changing $where 0 to $where 1. Send the modified request. If the response now states account locked, this indicates that the JavaScript code inside the $where clause has been executed. This confirms that the application is vulnerable to JavaScript injection. Now, we will use Burp Intruder to automate the process of extracting hidden user information from the application. In Burp Suite, right-click the modified post/login request and select Send to Intruder. Navigate to the Intruder tab. Modify the $where clause to the following. Define payload positions within the $where clause. This attack will attempt to enumerate object properties inside the database. Configure two payload positions. The first payload should contain numbers ranging from 0 to 20. The second payload should contain characters AZ 0 to 9. The professional version of Burp Suite offers ready-made lists with upper and lowercase letters and numbers. Click Start Attack and wait for Burp Intruder to analyze the responses. If you are using the Community Edition of Burp, this part will take longer than with the professional version. Sort the results by payload 1 and length to identify the correct response. The first field is username. Now we need to adjust the $where clause to extract another field. To do this, we need to change the 1 to a 2. Click Start Attack again. Sort the results by payload 1 and length to identify the correct response. The second field is password. Now we can test more digits, but to shorten this a little, we will use the digit 4. We change the 2 to a 4. Click Start Attack again. Sort the results by payload 1 and length to identify the correct response. We have identified a very interesting field. It appears to be a field for resetting passwords. We should make a note of the name of the field. Using the previously discovered vulnerability, we will now extract the password reset token and use it to reset the password of the user Carlos. Locate the get/forgot_password request in the HTTP history. Right-click and select Send to Repeater. Switch to Burp Repeater. In Burp Repeater, we will send an invalid request. The complete request should look like the request in the video, at least the first line of the request. Now we send the request to the application. Now we send a request without our changes. As you can see, there are no differences between the two requests. Now we submit the exfiltrated name of the password reset token field in the URL. Replace foo with the correct parameter name obtained from the intruder attack. Notice that we receive an invalid token error message. This confirms that you have the correct token name and endpoint. Now we switch back to Burp Intruder and adapt our request so that we extract Carlos' password. Keep the settings from your previous attack, but update the $where parameter as follows. Be sure to replace the token name with the name of the token you extracted in the previous step to reset the password. Click Start Attack. Sort the attack results by payload 1, then length, to identify responses with an account locked message instead of the invalid username or password message. Note the letters from the payload 2 column downwards. Switch back to Burp Repeater and submit the value of the password reset token in the URL of the get/forgot_password request. Right-click the response and select Show Response in Browser. Click Copy to copy the response. Open a new tab in Burp's browser to be able to insert the response there. A new password can now be set for Carlos. You can now log in with the user Carlos and the new password.